Good afternoon, everyone. Today, I'm going to explain the C++ program. So this project is a good example of OPP. So let's see the first part. A simple file structure, I think. So before we look at the C++ codes, let's look at a small text field called the file system text. So this file is not read by the program automatically. Instead, this is write by person. All kinds of folder and file structure that this program is designed to represent. So it helps us imagine the final result before we write the code. Yeah. For example, the line flow root cross tells us that there should be a folder name cross directly inside the root folder. Yeah. Um, let's see the field H, the blueprint of the field. These two lines are called header guard. So in the large C++ project, so the same header field might be included in many other fields. So if the same contact is copied twice, the compiler will get confused. So we should need these two lines. This plus field means the keyword class star definition of the new class field name field, right? So inside blanket, we first see the keywords the private. So this means the item list below it cannot be accessed directly from the outside the class. So they can only be researched through the class own function. This is the OPP idea. Yeah. And another one is the public, right? This can access directly. Let's move to the fail C++. This one. So this is a field building the field behavior. Yeah. This line, the test field. So this line means this is a constructor function that belongs to the field class. The double colon, it called skewer. The double colon means skewer resolution operator. You're right. And then this second constructor set two parameter n and e, so which represent the name and the extension that caller wants to give the field. This line, and this line, and this line, all called getter function. This getter name means the function simply returns the value stored in the private variable name. This one is just return the extensions, and this one in the same way, right? The function returns the value of the private variable extension, so the outside code can read it without touching it directly.
Next we will look at the folder.h. The folder class is more complex than the field class because a folder needs to keep track of its parents folder. The inside is it can and it can have many subfolders inside it. First, there are some include mm, the vector is needed because a folder needs to store a list of fields and a list of subfield folders, and a vector in C++ is a reusable list similar to an arrow that can grow and share it. Then, then lines, then this line, in this line, oh, in this line, the folder class stores 4 pieces of information like this for private information. The first name is hold the folder's own name as text, and the folder parent is a pointer to another folder object. It points to whichever folder contains this one. A pointer is simply a variable that stores the memory address of another object instead of storing the object itself. And then the public this is the constructor folder, takes a name and a optional parent pointer. The first equal to known pointer PTR is default value. This is the default. And then there's some variable. Then is the function. This for function lets all the code safely read the folder's information. The gets name returns the folder's name. Then the gets parent returns the pointer to parent folder. Then the gets files the vector gets files and gets subfolders returns the internal vectors directly. And the add file is a function that will create a new file object and add it into this folder using the given name and extension. Then the add folder declares a function that will create a brand new subfolder with the given name inside the folder. Yeah. Then is the function display current. The display current will show only the contents of this folder. And then is the display tree. Display tree will show this folder and every show stop folder underneath it. The parameter level controls how much indentation or spacing is used when printing, so that deeper folders appear farther to the right. It defaults to 0 for the very first call. Then is the bool search field. Search field will look sort of this folder and every subfolder underneath it. To check whether a field with a given name exists, it returns a true or false answer using the tab bool. That is the delete. That is a delete field will remove a field with a matching name from this folder. That is a delete folder. We remove a subfolder with a matching name from this folder. Then is next is find subfolder. This will search only among the direct subfolders of this folder and return a pointer to matching one or a known pointer if nothing is found. Folder. Next is the folder.cpp. Building the folder behavior. First, this line is the include. This line brings in everything this file needs. And next is the folder. Next, a new folder of jobs is created. The construction starts the given name into the provides variable name and stores the given parent pointer to the provides variable parents. From this moment on, the folder knows its own identity and knows exactly where it sits inside the larger tree of folders. And is this? The destruction runs automatically when a folder object is selected, and yeah, this is a delete the subfolder, and it's a looping. It's use a looping. Then this for short function simply returns the previous daughter that we discussed earlier. Gets name, gets back the first name, name, and gets parent, gets back the pointer to this parent. It's just a pointer, and gets file and gets subfolders return a vector. Give back a direct access to internal lists since they return reference to rather than copies. And then word folder add file. These functions First, check whether the given name N or extension E is an empty string. If either one is empty, the function uses sort to raise an exception, an error that stops the normal flow and must be handled as well. Next, the functions loops stores every file already stored in this folder, checking whether a file with the exercise some name already exists. If a name is found, another exception is thrown. Since two files in the name folder should not share a name, if both check pass, the function creates a brand new field object using using the function file and add it to the uh, end of the field's vector using passback. Then is the function add folder. This has a parameter with string n. It first checks that the new folder name is not empty and the source and exceptions. If it is, then draw. Then its loop solve the existing accepting subfolders to make sure no older subfolder already has this time. Solving an exception if a duplicate is found. Notice the arrow operator. Arrow operator because subfolders is a pointer to a folder. We use the when more better than operator instead of a dot. Yes. You call it this function. Finally, it's both checked pass. The and then the keyword this. Yeah, the keyword this is a special pointer that always refers to the current object. In other words, the new subfolder folders is told that its parent is the folder we are currently working with. The next is the display current. Yeah, it's the function display current. This function prints a simple summary of the current folder. It first prints the folder's own name. Yeah, that. Then it prints the word fields and loops sort every field. This is a looping and loops sort every field, every file objects in this folder, prints each one's full name such as reports.txt using a dash in front for a neat list style. After that, it prints the word subfolders and loops serve every subfolder print just its name. The function only shows what is directly inside the current folder. It does not look any deeper. Then is the display function display tree. This is one of the most interesting functions in this program because it is recursive. Recursive, meaning the function call itself is a recursive function. It first prints the number of spaces equal to level, which created indents indent indentation so that deeper folders are shown farther to the right, like a real folder tree. Then it prints the folder's own name. Next is loops through the file in this folder and prints each one indented one level deeper than the folder name. Finally, it loops through every subfolder and calls display tree, and the parameter is level plus 1 on each one. Because each subfolder calls this display tree again with one extra level of indentation, the entire tree, no matter how many levels deep, eventually gets printed correctly. Correctly. Yeah, the recreation. It returns. And is the search file, function search file. The search file is also recursive. It first checks all the fields directly inside the current folder. Yeah, like that. And if any file's name matches field name, the function immediately returns true. If no match is found here, the functions then loops of every subfolder and calls search file again on each one because each subfolder repeats the same process on its own fields and its own subfolders. The search eventually checks the entire tree, no matter how deep it goes, only if only if absolutely nothing is found anywhere does the function return false at the very end. Next is the delete field. This function loops stores the fields in current folder only. It does not search subfolders if it finds a field once a margin name is removed that file field from a vector using errors, and then the function ends immediately when returned. If the loop finishes without finding any match, the function throws an exception saying files not found, so the caller know that nothing was deleted. That's the delays folder. Yeah, the last function, the function delays folder. The function looks only among the direct subfolders When it finds a subfolder with a margin name, it stores two things. The first thing is called delete on the pointer, which fills first the memory and also triggers that subfolders on destructor, removing everything inside it as well. Second is cause errors to remove the now invalid pointer from the subfolders vector. If no subfolders with that name exists, the function throws an exception saying that founder not found. Okay, then is that oh fine and oh no that's it that is also that is really the last function the function name find subfolder. This function searches only the direct subfolders of the current folder. If it finds one whose name matches the folder name, it returns the pointer to the subfolder right away. If the loop completes without any match, it returns non-ptr sing sign signal in that no such subfolder exists exit here exists exists here. The function is later used to check whether the user can move into a subfolder by name. Yeah. Then okay. Okay, that is all my part.
This is the smallest file in the project, but it is where the program actually begins. The line includes the file system branch, bringing everything we need to use the file system class. The line uses namespace std include here too. That in this particular file is not strictly necessary since we do not directly add any std names inside the special main function, which is the starting point of every C++ program. We create a one file system object named fs pointer. Creating this object automatically runs its constructor, which builds the root folder as we saw earlier. Then we call fs pointer menu, which starts the interactive menu and keeps the program running until the user chooses to exit. Finally, return 0 tells the operating system that the program finished successfully without any errors.